So today I thought it'd be good to introduce you to ADLINK Edge and also the work we've done with Nvidia's DeepStream. First of all, though, I thought rather than jump straight into the demo of DeepStream, I'd explain to you a little bit about ADLINK Edge and what we've done and the tools that we've created. One of the biggest challenges we had was how do we efficiently provision devices and how do we do it so that it's not just a full-on manual process. Each element of our hardware comes with the ADLINK Edge platform installed on it. You can also install the ADLINK Edge platform as a package in an Ubuntu 18.04 operating system. But what you get out of the box with ADLINK Edge is the ability to discover it on the network. And we leverage the ADLINK data river for that. As soon as a device powers on, it immediately starts broadcasting its identity and registered status. And why we care about that is we have a tool called Edge Profile Builder. Edge Profile Builder has a vast array of functionality, and I will show you a live demo of all of this shortly. But what Profile Builder does, it discovers a device on the network. And then we have a couple of options. We can apply one of our ADLINK templates, so demos that show you simulated Modbus and vibration data. We've got templates that have AI tooling in them. And one of the templates I'm going to show you today is actually one that I've downloaded locally and configured my DeepStream app. So once I have my profile built, all my apps are configured, I then target a device. And the way I do this is via the data river. So the profile builder targets a device, sends a Docker Compose file across the data river. On the device, we have our Edge agent, which is listening to the data river and securely receives the Docker Compose file. It then unzips it and executes the Docker Compose file, which pulls down the Docker images from Docker Hub, in this case. It then starts the images, applies the XML configurations that are provided as part of the profile, and the apps run. So what am I going to show you today? I'm going to show you the ADLINK frame streamer, and that's where the vast majority of our video ingestion takes place. Whether that's a video that's just playing on a loop, as you'll see today, or whether it's live video from a webcam or from one of our smart cameras, we have the ability to take that data, create video frames from it, and put those frames on the data river. Now, why we do this is because we have several applications that are interested in that video frame, not just the one. One of them is our DeepStream inference engine and the video frames received to there. Also, if we decided to, we can also inject the video directly into DeepStream. But for the purposes of what we're trying to do here is reuse the video frame across the data river. So the training streamer uses it, captures training images, sends them to FTP or saves them to disk. But if we go back to the inference engine, once it's received the video frame from whichever source it's configured to receive it, it then pushes inference results to the data river. We have our stream viewer, and our stream viewer takes those video frames, knits them together in an inference result, and produces an RTSP feed. And it's completely up to the user how they consume that RTSP stream. It could be via a commercially available product, but as part of the user experience with Edge, we actually included the ability to view the stream within Profile Builder. I will show all of this as a live demo very shortly. The next app that we need to consider is our Node-RED app. So we took Node-RED and we created our own version of it, enabling us to create nodes that had data river input and output, and it allows us to drive real-world inference results. Going to go-to50.ai and going to the projects area, you'll see various projects where we've used Node-RED to drive elements in the real world. Next, I introduce the ADLINK Model Manager. It's very important for us that once we capture the training images, we give the user the ability to add the model to our model manager at the edge and then choose to which inference engine and when that model gets applied. And again, we use Profile Builder. It communicates with the data river, it discovers inference engines, it discovers model managers on the network, and then it instructs the inference engine which model it needs to apply from which manager. The inference engine then requests the change of model. The model manager sends it, the DeepStream inference engine receives it, unpacks it, applies it, and then starts inferencing off that information. So before I show you all this live as a demo, I thought it's best just to introduce Profile Builder. So Profile Builder is a collection of tools which include profiles, which are for the deployment and configuration of devices. We have our marketplace, we have device management, and you see at the top of the screen we have a vision tab. So let me introduce you to profiles. So a profile is a collection of applications, or Docker containers in this case. And you can see in here I have an NVIDIA DeepStream x86 profile already built with 8 applications in it, each with their various configurations. It's worth noting also that besides ADLINK apps, there are also third-party apps in this profile. For example, Portainer, which is one of the tools that we help us to manage at the edge. If I click into that, you can see there's no option to configure it at all. But if I go into a DeepStream app, you can see the configuration that I can do. I'm configuring my analytics pipeline here, setting my source, in this case the data river, setting my inference, and by default we ship with 2 models that get applied. I also have a data river inference output and a data river video frame output. And this is when we want to overlay the 2. I also have the ability to add files, set Docker options, and also view the documentation for the app. What's really important here is the ADLINK marketplace. So our marketplace by default comes with Docker Hub's official marketplace, Portainer, and our public repository. But as you can see, I've added in a 4th repository. And that's because what Marketplace allows you to do is to connect to your own Docker Hub repository. For example, if I wanted to install Influx, I could simply add in the Influx credentials, enter my username and password, and it will then go to Docker Hub, check the API against my credentials, and it adds it into Marketplace as a store. And if I scroll down to the bottom, you'll see InfluxDB has now been added. Now, some of our customers don't want to use Docker Hub. They want to use a local repository inside the network, or even a repository that they host in the cloud somewhere. And we've catered for that as well. So when adding a store, I can also add a third-party repository. And as a system operator, we'd expect our customers to know these details. The one thing to make sure is that the catalog that's being used is a Docker version 2 catalog. That's the only restriction on what the user can do. So now to provision our device. So as you can see, detected on the network is the DLAP that I mentioned in the previous diagram. And to register that using the local profile, I simply register the device, select local registration. I do have the ability to deploy using one of our cloud partners, but in this instance, I want to just deploy the profile directly. I give it an alias, and the alias is what will be broadcast across the network. It's more of a user-friendly name for the device rather than the standard name that all of the devices ship with, in this case the DLAP, as you can see in the background. We also provide you with the IP address and various other information if you desire it. I then have the ability to choose whether to use a template or a local profile. If I select a local profile, you can see I have the NVIDIA DeepStream x86 profile with the 8 applications that I mentioned previously. To apply that profile to the device, I simply click Install. As you can see, the alias and the user-friendly name has now changed, and the device is now being marked as registered, and my profile is currently being deployed. Once the profile is being deployed, simply click and refresh. We can see that Portainer is running on the device, as I can see the Portainer logo, and I can click in there to manage the device if I wish. However, what we also offer via our Edge agent is just the ability to click on the device and be able to see some basic Docker information. I can also see information on the device. I can see whether SSH is enabled, and via this and also our Edge agent, I can disable and enable SSH if I desire. Now to see what's happening via our DeepStream app. So our DeepStream app is now consuming A simple refresh of the screen also then shows that my DeepStream inference engine is running. Now to view the output of this, I simply switch to my streams view and click into the stream to view what's going on. As you can see, it's showing the inference results, picking out people, fire hydrants, cars, trucks. That's because it's running an object detection model. If I close this view now and go back to my inference engine, refresh my screen, I've added a pedestrian detection model against my model zoo, and to simply apply that to the DeepStream app, I simply take the model and drop it onto the inference engine that I've chosen to, and then set to apply it. If I now go back to my stream and click into it, I'll see that it's applied the new model and it's only registering pedestrians now rather than the objects that were previously being detected. So this is obviously a manual way to create a model and then to apply it. But what we have been working with is our partners to actually try and automate this process a little bit more. As you can see from this graphic, we are capturing training images, streaming them to, in this case, AWS, but we've also done the same with Azure. And we're then collecting the training images and refining the model that's already applied at the edge through SageMaker, and then optimizing the model. And then we have an app that isn't in the profile I just showed you, which is our AWS model streamer. And what that does is it automatically receives a notification from an S3 bucket that a new model has been created. It immediately downloads the model and automatically applies that to the DeepStream inference engine, allowing us to create a constant loop of being able to capture and train models via images, via AWS, and automatically have it deployed when the new model is ready.